We've been looking at collisions, and there is one topic, one subtopic within the realm of collisions that's worth taking an extra second on. It's not going to be anything particularly difficult or even new, honestly. It's just if you come across this sort of problem, if you come across this sort of topic, it helps if you've seen it once before. So we are going to talk about collisions in reverse. When we do a collision, especially when we do a stick-together type of collision, we get something that looks like this. Mass 1, V1, Mass 2, V2, and then afterwards, maybe we can even time it and dial it in just right so that these momenta exactly cancel and we get the total mass with a final speed of 0. Like, that's possible, right? If we have like a 5 kilograms at 4 meters per second, a 4 kilograms at 5 meters per second, then our initial momentum's 20 minus 20 is 0, so we end up with nothing. In this case, we are looking at a before and an after. But what happens if we just kind of reverse time? What if we take this thing and put it over here, and this thing and put it over here? Okay. Well, that could kind of work, I guess, before this happens and afterwards they're moving toward each other. Maybe that doesn't make so much sense. So maybe I'm going to take this one and put it here. And then this one and put it here. That'll work. Now I have this system that before just kind of sits there, and afterwards I have two blocks that are moving away from each other. This is a collision in reverse, or an explosion. And now, just to make sure that we've got our before and after really clear, I'm going to take all this stuff and put it to the right side, because that'll make it a little bit easier to see it as a before and after. But I didn't really do anything. I just looked at this same process kind of backwards. So we'll do that. We will figure out the momentum situation and see if we can get there. And it turns out we can. We actually already did, right? We have an initial momentum of 0. We have a final momentum of 4 kilograms times negative 5 meters per second plus 5 kilograms times positive 4 meters per second equals 0. We start with one piece. And now, it might not actually look so much like this. It might be that we start with one piece that looks like this, and then we end up with two pieces that move away from each other, which is fine, or 3 pieces, or however many pieces. We could even add a little bit more to this. Maybe this is a firework, and this thing starts off with some vertical velocity. Well, then instead of these arrows, I might have those arrows. The horizontal components are going to have to, the horizontal momentum is going to have to work out to still be 0. And the vertical momentum, if this is a total of m, the vertical momentum is going to have to be an m1 v1y plus m2 v2y, and that better be equal to m, times v. There's nothing particularly fancy or different going on. We're still just doing momentum conservation. We're just doing it backwards, that's all.